second part in this section, we are going to talk about a measuring unit. But before we do that, what is meant by a dozen? A dozen is a measuring unit of 12. If I said 12 books, it means dozen books. The same idea is applied in chemistry, but our dozen is called the mole. The mole is a measuring unit in chemistry, but the mole or 1 mole equals 6.022 times 10 power 23 atoms of anything. So if I said I have 1 mole of sodium, it means we have 6.022 times 10 power 23 atoms of sodium. The molar masses. The molar masses of any substance is equal to the mass in grams of 1 mole. So the molar mass is the mass of 1 mole, or the mass of 6.022 times 10 power 23 atoms. If I want to calculate the molar mass of elements, the molar mass of 1 mole of carbon, we are going to look up carbon in the periodic table, and the number written below carbon is 12.011 grams. So its molar mass is 12.011 grams. The molar mass of 1 mole of calcium, we are going to look up calcium in the periodic table, and the number written below calcium in the periodic table is 40.078 grams. So its molar mass is 40.078 grams. Then we have molar mass for compounds, which means we're not talking in terms of atoms anymore, we are talking in terms of moles of atoms. Moles of atoms. So if we said potassium chlorate, potassium 1 mole atoms of potassium, chlorate 1 mole of atoms of chlorine, O3 3 moles of atoms of oxygen. So we are talking in terms of moles of atoms, not atoms, because atoms is very, very small. So we are going to talk from now in terms of moles of atoms, not just atoms. So how to calculate the molar mass of a compound? By adding the molar masses of each atom in the compound. So what is the molar mass of potassium chlorate? We are going to look up the numbers written below potassium, chlorine, and oxygen in the periodic table. The molar masses for potassium, chlorine, and oxygen. Then, how many moles of atoms we have? We have only 1 mole of atoms of potassium, so we are going to multiply the atomic mass of potassium by 1. Then we have 1 mole of atoms of chlorine, so we are going to multiply the atomic mass of chlorine by 1. We have 3 moles of atoms of oxygen, so we are going to multiply it by 3. So we are going to add them all together, and we will have the molar mass of potassium chlorate. We have another practice in your books, page 227. Question 1. How many moles of atoms of each element are there in 1 mole of the following compounds? The second one, aluminum sulfide, Al2O3. We have 2 moles of atoms of aluminum and 3 moles of atoms of sulfur. The second one, sodium nitrate. We have 1 mole of sodium, 1 mole of atoms of nitrogen, 3 moles of atoms of oxygen. Barium hydroxide, we have 1 mole of atom of barium, 2 moles of atoms of oxygen, 2 moles of atoms of hydrogen. Question 2. Find the molar mass of each of the compound listed in item 1. The molar mass of aluminum sulfide, we are going to look up the molar masses of aluminum and sulfur, the number written below each element in the periodic table, and we are going to multiply it by the number of moles. So the molar mass of aluminum multiplied by 2, and the molar mass of sulfur multiplied by 3. Sodium nitrate. We have only 1 mole of sodium, and then we are going to multiply it by the number written below the sodium in the periodic table, which is the molar mass of sodium. Then we are going to multiply the nitrogen by 1, and we are going to multiply oxygen by 3. Barium hydroxide, we have 1 mole of atoms of barium, multiply the number written below barium in the periodic table, and we have 2 moles of oxygen. We are going to multiply the number below oxygen by 2, and 2 moles of atoms of hydrogen, so we are going to multiply the number written below hydrogen, which is its molar mass, by 2. Third part in this section is using molar mass as a conversion factor. What is the mass of 2 moles of water? 2 moles of water. We are going to look up hydrogen and oxygen in the periodic table and their molar masses, the number written below each element in the periodic table. So the molar mass, the mass of 1 mole of water will be the molar mass of hydrogen multiplied by 2 and the molar mass of oxygen multiplied by 1. So the molar mass, the mass of 1 mole of water is 18.015 grams. So the 1 mole is 18.015 grams. This is the mass of 1 mole. What about the mass of 2 moles? If I want the mass of 2 moles of water, 1 mole is 18.0115 grams. 2 moles is, yes, we will multiply the mass of 1 mole by 2. What we just did is we multiplied the number of moles I need by the mass of 1 mole, which is the molar mass. This leads to this relationship. If I want the mass in grams, we are going to multiply the number of moles, which was 2, by the molar mass of water or any other compound. So this relationship is very, very important. The mass in grams, number of moles, and the molar mass. The molar mass is the mass of 1 mole, which we already know, and we will always know in any problem we can calculate it from the periodic table. So we are going to be given one of these two and he will ask about the other one. For an example, how many moles in 3.82 grams of sulfur dioxide? How many moles? We have this relationship, the number of moles. He asked about the number of moles. So the number of moles will equal to mass in grams over molar mass. So the number of moles, mass over molar mass. The mass is given in the problem, which is 3.82, and the molar mass we can calculate it from the periodic table, look up sulfur and oxygen, and we will find that it equals 64 grams. So the number of moles will equal 0.059 moles. What is the mass in grams of 3.04 moles of NH3? What is the mass in grams? Now he asked what is the mass in grams. The mass in grams from this relation equal the number of moles times molar mass. So the mass equal number of moles multiply molar mass. The number of moles is given in the problem, 3.04, and we can calculate the molar mass of NH3 from the periodic table. So the number of moles multiply the molar mass will give us the mass in grams. Now we are going to solve the practice in page 230 in your books. Question 1. How many moles of compounds are there in the following? How many moles? How many moles? So he asked about the number of moles. The number of moles equal the mass over the molar mass. So the first step is to calculate the molar mass. Calculate the molar mass for NH4 by 2SO4. So the atomic mass or the molar mass of nitrogen multiplied by 2, the molar mass of hydrogen multiplied by 8, the molar mass of sulfur multiplied by 1, the molar mass of oxygen multiplied by 4. Now we have the molar mass for the whole compound. Then we are going to calculate the number of moles. The number of moles equal the mass over molar mass. The mass is given in the problem 6.60 grams over the molar mass I just calculated. The second one, the molar mass of calcium hydroxide. We have 1 moles of atoms of calcium, so the molar mass of calcium multiplied by 1. We have 2 moles of atoms of oxygen, so the molar mass of oxygen from the periodic table multiplied by 2. And we have 2 moles of hydrogen, so we are going to multiply it by 2. Now we have the molar mass of calcium hydroxide. He asked about the number of moles, so the number of moles from this relationship equal the mass in grams over molar mass. It's given in the problem 4.5 kilograms, so I have to convert it into grams by multiplying it by 1000. So 4.5 multiplied by 1000 over the molar mass I calculated in the first step. Now we have the number of part part in this section is another relation. We already said that 1 mole of anything equal to 6.022 times 10 power 23 atoms or molecules. So if I want to know how many atoms or molecules are in 2 moles, we are going to multiply this number by 2. This number is called Avogadro's number. So Avogadro's number equals 6.022 times 10 power 23, and you will have to memorize this number. So if I want to know how many atoms or molecules in 2 moles, we are going to multiply Avogadro's number by 2. So the number of atoms or molecules will be the number of moles multiplied by Avogadro's number. So this leads to the second relationship in this section. The number of molecules, the number of moles, Avogadro's constant. Avogadro's constant is always known as we have to memorize it. So in any problem, he will give us one of these two, the number of molecules or the number of moles, and he will ask about the other one. For an example, how many molecules are there in 3.04 moles of NH3? How many molecules? From the relationship, he wants the number of molecules. The number of molecules equal number of moles multiplied by Avogadro's number. The number of moles are given in the problem, 3.04, multiply Avogadro's number, and now we have the number of molecules. We will be back in page 230 in the book, question 2. Question 2, how many molecules are there in the following? 25 grams H2SO4, 25 grams. And he asked about how many molecules. How many molecules? He wants the number of molecules. The number of molecules equals the number of moles multiplied by Avogadro's constant. But the number of moles are not given in the problem. Instead, he gave us mass in grams. So we are going to use the first relationship to get the number of moles. The number of moles equal the mass over molar mass. So the number of moles, the mass in grams, which was given in the problem, over the molar mass. Now we have the number of moles. We can calculate the number of molecules by multiplying the number of moles by Avogadro's constant. The number of molecules, number of moles multiplied by Avogadro's constant. The number of moles I already calculated in the first step, multiplied by Avogadro's constant, and we have the number of molecules. The second one is the same. We have mass in grams, and he wants the number of molecules. The number of molecules equal the number of moles times Avogadro's constant. So we have to calculate the number of moles from the first relationship, which equal mass over molar mass. The mass is given in the problem. The molar mass we can calculate it from the periodic table. Now we have the number of moles. So in order to calculate the number of molecules, I'm going to multiply the number of moles by Avogadro's constant. Problem 3. What is the mass in grams of 6.25 moles of copper 2 nitrate? As we already know that copper 2 is from the D block, so the charge is given by positive 2 and the nitrate NO3. So the correct formula for copper 2 nitrate will be CuNO3 by 2. He wants the mass in grams. So from the first relationship, the mass in grams equal the number of moles multiplied by the molar mass. We have the number of moles given in the problem, 6.25 grams, and we are going to calculate the molar mass, then multiplied by the number of moles. Now we have the mass in grams. The fifth and the last part in this section is something called percentage composition. To find the mass percentage of an element in a compound, we divide the mass of that element over the mass of the whole compound, then we multiply it by 100. For an example, find the percentage composition of H2O. H2O consists of two elements, hydrogen and oxygen. So we want to know the percentage of hydrogen in water and the percentage of oxygen in water. To do that, the first step is to calculate the molar mass of water, H2O. We are going to look up the numbers written below hydrogen and oxygen in the periodic table. Then we have 2 moles of atoms of hydrogen, so we are going to multiply it by 2. And we have 1 moles of atoms of oxygen, so we are going to multiply it by 1. Now we have the molar mass of H2O. Then we are going to calculate the percentage of hydrogen in water. the percentage of hydrogen, we are going to divide the mass of hydrogen, only hydrogen, which is 2 times 1.008, over the mass of the whole compound, the molar mass of water, which is 18.015. Then we are going to multiply it by 100 to get the percentage 11.19%. To calculate the percentage of oxygen, we are going to divide the mass of only oxygen, which is 15.999, over the mass of the whole compound, which is 18.0115. And then we are going to multiply it by 100 to get the percentage 88.81%. Then we are going to solve the practice in your books, page 232. Find the percentage composition of the following: PbCl2, lead to chloride. We have 2 moles of atoms of chlorine and 1 moles of atom of lead. So lead is multiplied by 1 and chlorine is multiplied by 2. Now we have the molar mass of the whole compound. To find the percentage of lead, we are going to divide the mass of lead over the mass of the whole compound. Then we are going to multiply it by 100. And to find that percentage of chlorine, we are going to divide the mass of only chlorine over the mass of the whole compound. Then we are going to multiply it by 100. Now we have the percentage of both elements. Second one, BaNO3. BaNO3, we are going to calculate the molar mass. We have only 1 moles of atoms of barium, so we are going to multiply it by 1. We have 2 moles of nitrogen, so we are going to multiply it by 2. And we have 6 moles of oxygen, so we are going to multiply it by 6. And to calculate the percentage of barium, we are going to divide the mass of only barium over the mass of the whole compound. Then we are going to multiply it by 100. And to calculate the percentage of nitrogen, we are going to divide the mass of only nitrogen over the mass of the whole compound. Then we are going to multiply it by 100. And to calculate the percentage of oxygen, we are going to divide the mass of only oxygen over the mass of the whole compound. Then we are going to multiply it by 100. The second question, find the mass percentage of water in ZnSO4 7H2O. We are going to find the molar mass, the first step, to calculate the molar mass for the whole compound. We have only 1 atom of zinc, so zinc multiplied by 1. We have only 1 moles of atoms of sulfur, so we are going to multiply it by 1. O4, we have more moles of atoms of oxygen, so we are going to multiply it by 4. And we have 14 hydrogen, 7H2O. The 7 is multiplied in the whole water molecule, so we have 14 moles of atoms of hydrogen, so we are going to multiply it by 14. Then we have 7 moles of oxygen, so we are going to multiply it by 7. Now we have the molar mass of the whole compound. To calculate the percentage of water, we are going to divide the mass of the water, which is 7H2O, which is 14.1008 plus 7 times 15.999, over the molar mass of the whole compound. Then we are going to multiply it by 100 to get that the percentage of water is 43.85%.